I'm going to do a new set of videos here, doing some of the post-processing and kind of play my screen as I go through some of that. Enjoy. Okay, the first thing I need to do is set up directory trees and kind of show you what I've got here. This is where I have my light frames. Go up here a little bit. So the light frames here, see for the different things I imaged. Yes, I did image the moon, but mostly stay with deep sky. C20 is one of those. Light frames recorded into this directory, and the camera settings as well, and text files. Show you what one of these files looks like. This is some of the settings. Tells you what the camera is, what the image, what the image sensor model number of that, serial number, even the light frame, the type of frame, the debayering, hardware binning, and, low noise. We're using each pixel as one pixel. You can, when you bin, you can actually do have 4 pixels combined into one, or even 16 combined into one, 9 combined into one. There's different arrays you can do that way. I don't use 2 unless if the seeing is real bad, the image is not real stable, and I'm using a long focal length. I'll go to a binning of 2 or 3, 2 by 2, 3 by 3, and get the 4s, 9 into 1. That increases the brightness, and if the image is not that stable, then it really doesn't matter. It's not going to take away the image resolution. But if it is a really good seeing conditions, then it might. Just depends on the situation. That's for another video. Capture area, that's 3008. This particular camera. It's a square imager, so it's the height and width are the same. Output format. Anyway, it goes through all this. Even has the temperature. The exposure is 15 seconds. What else you have? You have the temperature down here somewhere. I'm gonna find it. Yeah, here we go. It's the temperature of the camera sensor at the time that this image was taken. So you can see how well they match with other, like the dark frames. It's important that this temperature be within a degree or 2. And I got a little bit of a allergy hitting my speech, so you'll have to excuse that. Anyway, so one of the first things I do is I set up a processing tree, and first thing I do is inspect, and I do pre-processing where I stack images, and I do post-processing where I stretch the image, get rid of some of the noise. And then I take it once I get as much as I can do in serial, which is what I use for most of my image processing. Take it into GIMP and do a little bit of touch up, export it into a JPEG. I usually put it's a FIT file in the serial, but when I take it into GIMP, I do it as a TIFF file, and then I take the TIFF and convert it to JPEG to put it on social media. So I have inspection, pre-processing. I did copy the lights into here, and I'm going to go through each of these images, and delete the ones that are not worth keeping, that I don't want to have it influence the average image. So I'll be doing that. I'll do that off to the side, but I'll show you how to set this up. We set the main screen here. And just to make sure I'm on the wrong project there, that's the new project. And I'm going to go into the pre-processing, or no, inspection, and inspect it. Open that up. And now all of our processing will take place in this empty directory. It'll pull those into a sequence of images. And I'll just kind of show you. So we're going to go back to here. The light frames. And we're going to Control A. That's all of these frames. And we're going to add them to the list here. We want a debayer to get our color out, since this was a color camera that I'm using. There's mostly two types of cameras. One-shot color, which is it's initialized OSC, and then there's the monochrome camera, giving you just one color image. Basically a black and white camera. So we're going to do that, and we're going to name the sequence. Let's do inspection. And I'll short it to inspect. And hit the convert button, and it converts those. And when we do that, this inspection, it will fill these up. These are the files being brought in. The debayering is where it's converting the color over patterns. So this is much better. I had flipped the images on the previous project and it messed up the debayering filter. So it's matched correctly now. So this is going to take a while. There's 100 images that this has to go through. So yes, it's going to take a while to get through all 100. And it doesn't do them in any order. You can see where it's doing 77, 76, 78. It's kind of multiplexing things. And we're using 12 processors internally. That's one thing I like about this program. It gives you a feel for what it's doing in your computer system while it's doing this. And we have this. This is I think the first image. You can see where there's stars. It looks kind of boring. It looks like just a small star field, but actually when you auto stretch it, then you see all of the background. You can see some haze here. That's the nebula that I'm trying to pull out of it. And you're probably wondering what the heck is we're doing here. So we go to the sequence. It's in the sequence of files. And this is the list of files that it's in. Now we can go through and actually, this is the reference image. The next image is not a reference. So we're going through these different files. And one thing you can see, this kind of change. You can see the noise kind of changes. This is going to get averaged out when I average all these frames together. The stars that are in the same place, this nebula, anything that doesn't change will be brought out more prevalent. And you can see going 5 to 6, that image moves a little bit. That's the dithering that we did when we recorded it. If you watch my other video, you'll see that happening. And mostly what I'm looking for are any, there would be, if a satellite flew over or an airplane, you'll see streaks. Some of the smaller satellites you can just leave in there. I've been told that that gets averaged out pretty well. But the airplanes, not so much. Those are bigger. Those are much bigger, and they do happen. And again, we're using my down arrow key, going through all of the images quickly. So far, I did pretty good on this run. There was nothing came up on it. It's unusual, but that's the end of that. So I'll keep all those files. I click Control W to close out of that. That closes the sequence as well. Delete those files. Go to the next image. Lights and do sort by type, and I'm going to come down here, space that, copy, and paste. Yeah, and these two, I don't think I had any issues with these. So let me pause the video, and when I come to some, I'll point it out. Okay, I'm back here on the, you see C33, it's a nebula. It's the, I call it the Halloween Nebula. It's the Veil Nebula here. And going through here, there's one that sticks out. Looks like when I was observing out in the parking lot, probably had a car drive up and shine lights. And this happens sometimes. And get light. So that's an image that I don't want to have that affect my average image. It's bad. It's defective. That's number 65. So I have to find that image here. And I believe it's going to be in sequence 65. Instead of deleting that, what I do, create archive. So again, this is number 65. Cut. Paste. And we'll see if we find any more defective ones. And so far, so good. 100. So just one bad frame. It's not bad. Okay, I want to take this opportunity to talk about calibration frames under this directory here. Shows you all these are the images that I took the other night before last. And I took calibration frames at the end. I actually took dark frames. Dark frames are basically the dark current in the camera. Basically, when you have a camera with the cover lens on it, which is what I do, is cover up the telescope, leave the exposure frame, or set the exposure frame to the same as what I took the light frame. The lights are the actual image that I was interested in capturing. So setting the exposure time of the darks to the same as the lights. When you go into post-processing, you subtract out the dark frames from the light, and that accounts for the noise generated by the camera itself. And the flat frames are the imperfect the noise from that, or it's not really noise, but it's distortion in your image. The distortion there is due to imperfections in the optics, and also dirt on the optics, and most of it is dirt on the actual camera sensor window. There's a clear window that goes in front of the camera sensor on these astronomical cameras, and they do tend to collect dust once they're exposed to the outside air for very long. It doesn't take that long to actually get what's called dust bunnies, and so that the flat takes into account to that, and also any vignetting from the telescope. Some of the larger sensors experience that. This sensor, well, actually, with this telescope, it's not too much. With my larger telescope, my Celestron, vignetting is a big problem. It's actually a dark. The image is darker around the edges, the outer fringes of the image. The dark flat it's a dark with respect to the flat. It's just I set the exposure to the same as the flat and take them with the lens cap on again, and it accounts for dark currents at the exposure length of the flat, and those get subtracted from the flat. So the calibrated flat is the raw flat is the optics distortion in the optics, and also noise from the sensor itself. The dark flat is just the noise in the sensor, and when I get calibrated flats, I'm subtracting that noise out, and I'm left with only the distortion in the optics, and that gets divided. So basically, when you get a calibrated light frame, you're subtracting the dark at that exposure, and then you divide it by the calibrated flat, which is the flat minus the dark flat, and that gives you a calibrated light frame. So the first step in doing any post processing is to get to the calibrated light frame, and I start by generating the master files from all these, because there's 100 images on each one of these that I do. It's a little higher than what's recommended, but I've also read where if you don't take enough of these, they'll actually introduce noise instead of taking it away. So I go to the extreme and get 100 frames of each. It doesn't take a lot more trouble, and it prevents extra noise. So without further ado, I'll bring up Cyril, and we'll start on these calibration frames. Move this off the screen. I'm going to use it for reference. Set up this home position, and go back to there. Calibration, and we're in this directory here. And one thing I forgot to do is I need to go in a modified Oh, so I did check right quick. I modified the script file to get all the files at one time. I need to go back and check. Master. Masters. Make calibration masters. Okay. Looks like we did. Okay, so we have that. So that is correct there. So I'm going to go ahead and execute the make calibration masters, and that will start working on those directors. It's stacking, so it actually is finding the files that I generated. It's going to calibrate those. Go over here, bringing this up so it's actually this directory called process. That's where it's processing everything. So it's generating the bias files. That's my dark flats. Processing all images in their sequence 100. Stacking result will be stored as a 32-bit image. Using 51 gigabytes. Interesting. So now it's going through the flat frames. Okay, so it did the dark flats, and now it's doing the flats themselves. And now this is where the magic is happening. It's calibrating the flat frames. Yeah, this PP is so what we're seeing in these files. The file is loading the flat, or reading the raw flat, subtracting the dark flat, and it's saving it to the PP flat, PP underscore flat. So the PP stands for preprocessed. It's preprocessing the flat, which is basically getting the calibrated flats. And we got a little bar down here that tells us our progress. It's getting fairly close to being finished with the flats, and then we'll go to the darks. And the darks will go fairly quickly. Reading the flats. Stacked them. So now we have a master flat. So if we go to bring up the directory again, we have these masters. So we have the master bias, which bias stacked we won't use. That was used to generate this flat stacked, which we will use, and we'll get another some dark stack files that we will use in the different when we go to calibrate our lights. Execution failed. Dark 8. No such file or directory. Interesting. Okay, so we got some debug to go through. Let's go see where our problem is. Dark. Okay, see what the problem is. It's looking for just dark 8 and dark 15. Okay, so we will. Easy way to fix that is dark 8 and dark 15. Okay. And so we're going to have to go through this all again. So I'm just going to go ahead and delete what I've already done. Redo it, pause the video so you don't have to suffer through the whole thing. I'll go back and continue when I get to this point. Okay, we're back now. Looks like it didn't take as long as I thought it would. Evidently it used what was in memory to redo the flats and the dark flats. And so it's actually doing the darks now. It's working on 100. It's done the 4-second or 8-second stacking sequence of 8. Looking to see what it's been doing here. So it's done the 8-second, started stacking. And then it will get to the 15-second. Darks, I believe. Let's see what we get here. Let's see. So 8, yeah. So the next one is to do the 15. So it's nice you didn't have to made my mistake and now I'm back on track again. Yes, those are back in. Started stacking sequence dark 8. So it's taking a while to actually go through and take the average. It's these averages. If there's a big discrepancy between in any of them, it reject it. It either, I'm not sure how it processes, but it throws that at least the pixel, if not the whole image, out. So they have to be fairly within reason before they're considered an average, a candidate for averaging. And I think that's what takes this so long when it's processing. But it's basically averaging 100 images, 100 dark images, taken at 8 seconds. Now it's doing the dark 15s. Calibration process. Okay, so it's in the right place. Stacking sequence dark 15, processing all images in the sequence 100. It's 32-bit image, no registration layer passed. Ignoring registration data, using 51 gigabytes of memory. 12 parallel blocks of size 250 for stacking. Start stacking. Okay. So it is finished. Looks like. Okay. So let's go look at what we have here. We'll look at each master. Flats. Okay. So we'll look at the 15-second dark in the flat frame. Calibrate those. Okay, so this is the dark frame. Doesn't look like anything but just a dark frame, but that's because we're looking at the linear pixels. When we auto stretch it, then we see the noise. We see some bright specks here. Those are what's referred to as hard. They look like stars, but what they are is hot pixels. That's what gets subtracted out. So those could actually appear in the image that I took. They would show up as stars that really aren't there. And so to get rid of those, that gets subtracted out. That's why we do calibration frames in astronomy. So I'll go back to the linear, and now let's take a look at the dark flats, masters. And now we'll look at the flat frame. And so this is in the linear, so it's kind of grayish, and it is bright in the middle and goes out. So there is vignetting. Yeah, I was wrong about that. I didn't think there would be any vignetting in this image, but there evidently is. So this telescope does show some vignetting. Okay, and so this, yeah, we can actually stretch it. We do a stretch. It makes the bright really bright, the not so bright darker. So there's really no advantage to stretching it. Well, this is an interesting view of that. I don't see any dust, but let me go back and re-stretch that again. Stretch. See if any dust particles are on the image. You may not see it on your screen as I get some dirt, but that's dirt on my actual computer monitor. Oh, I got little white pixels there. That's interesting. Anywho, so that will maybe drill a hole in my light, but it won't be that obvious. Okay, that's enough of this part. So that's the calibration frames, and I'm going to end the video here and continue on. Next video will be actually processing an image itself. Or at least one of the images. Might do 2 or 3 depending on the length of the video. Don't forget to look up and like and subscribe. Photons from space. Bye for now.